Let's solve a problem involving static friction on an inclined plane. You put your sneaker on an adjustable wooden inclined plane. Raising the inclined plane slowly, you determine that the sneaker starts to slip at an angle of 40 degrees. What is the coefficient of static friction between the sneaker and the inclined plane? Let's draw a diagram to understand what's happening. We have an inclined plane that makes an angle theta with the horizontal. On this plane, we place a sneaker. When the sneaker is at rest on the incline, there are several forces acting on it. Let's analyze these forces. First, we have the weight of the sneaker, mg, acting straight down. We can break this weight into two components, one parallel to the incline and one perpendicular to it. The normal force from the surface acts perpendicular to the incline, and the force of static friction acts up the incline, opposing the component of weight that's trying to make the sneaker slide down. At the moment just before the sneaker starts to slip, the static friction force reaches its maximum value. This maximum static friction force is equal to the coefficient of static friction times the normal force. At this critical angle, the component of the weight parallel to the incline exactly equals the maximum static friction force. This gives us the equation, mg sine theta equals mu s times n. And we know that the normal force n equals mg cosine theta. Substituting the expression for n into our equation, we get mg sine theta equals mu s times mg cosine theta. The mg terms cancel out, giving us sine theta equals mu s times cosine theta. Solving for mu s, we get that mu s equals tangent theta. Now we can plug in our angle. The coefficient of static friction equals the tangent of 40 degrees. Using a calculator, we get that mu s equals 0.84. This means that the coefficient of static friction between the sneaker and the wooden inclined plane is 0.84.